Retargeting CAD data for offline rendering or real-time applications is traditionally a very difficult process. Typically, it involves recreating the object manually. This is due to the fact that it's nearly impossible to remove large amounts of data while preserving shading and general mesh quality. Additionally, there are no automatic tools available that can handle large datasets with thousands of objects or millions of polygons. Tessellation quality of CAD meshes can also vary greatly between tools, resulting in common issues like broken UVs and on-seamed or on-bridged CAD patches, which lead to drifting or swimming in the optimized asset or even invalid normals. All of these issues make it very difficult to establish a clear workflow on how to bring these assets to life without recreating them manually. This is about to change because with InstaLOD, retargeting CAD data into any 3D scenario becomes a trivial task. In this video, we're going to focus on using InstaLOD's powerful and fast polygon optimization technology. In later videos, we will focus on using Occlusion Culling to remove hidden faces and InstaLOD's remesher to bring even the most difficult topologies into a VR scenario. The first CAD example that I want to show you is this car hood, which is generally considered to be one of the most difficult for any optimization tool because of the precise shading, and we really want to keep that intact. When you load your CAD assets, you should always make sure that the scaling matches your settings in Maya. So if you set up Maya to be 1 centimeter to 1 unit or 1 meter to 1 unit, you should make sure that the scale of the asset you loaded matches your settings in Maya. So in this case, it matches nicely. So what we're going to do here is we're going to optimize this down very heavily, and instead of using percent triangles, we're going to let InstaLOD decide the best way before it starts to error out and it continues to keep all the shading intact. So we're going to use maximum deviation, and we're going to set this to 0.05. And this car hood does have UVs, but as you can see, the UVs are quite messy, and it doesn't make sense for InstaLOD to try to retain them at the cost of the visual quality to the mesh. So what we can do is we can set texture importance to off. The reason for this is that most CAD tools either generate no UVs at all or broken ones. In this case, they're just messy and unusable, which makes optimization rather difficult due to the splits. So we're not going to let InstaLOD consider those right now because we can recreate those later. So we're going to turn that off. So now that we've dialed in our optimization settings, let's go ahead and hit Optimize Selected Meshes. And we'll see that very quickly we've gone from 70,000 triangles down to 11,000. And one of the things to notice is that all the shading was kept intact very precisely, and all of our panel lines still look very, very clean. So we've done a really good job of optimizing this while still maintaining the normals and shading from the original. Now let's see if we can take this a little bit further, and let's go down to 0.1 for the maximum deviation and hit Optimize Selected Meshes. So again, very quickly, we're down to 7,000 from 70,000 polygons. So we're about 10% of the original, and it still looks very nice and clean. So let's go ahead and remove this other one, and let's do a test and put on a Phong shader and really make sure that we really do have good shading on here. So as you can see, we still have very precise hard lines in the reflections. And we can put a fully reflective material on this and render it and still come away with a good looking product. Now, because we removed the UVs, let's go ahead and put some back on. You can see there's no UVs on this model anymore. So let's go over back to the InstaLOD tab, and we'll scroll over to UV. And from here, let's use an unwrap strategy of hard surface axial for this car hood. All right, let's unwrap the selected meshes very quickly. And as you can see, we have some new UVs for our car hood. And that's it. Very quickly, we have optimized heavy CAD data, kept all the shading, and created UVs at the end. So now we're ready for a real-time application with this asset. So for this next example, we're going to look at this hammer, and this CAD data, if something could have gone wrong with the tessellation, it did. And if we look at it, one of the things to note first is that we have some gaps here in between the patches. And we also have some bad normals here as well. So let's take a look at a couple of other things. If we turn on the wireframe, as you can see here, you see we have some very long, thin triangles here, and then it goes right into some very heavily tessellated geometry here for some reason. And, if we go down and we look at the bottom, one half is fairly clean and the other is very messy. So let's see what we can do with InstaLOD to try to clean all this up. So what I'm going to do is, again, I'm not going to use percentage triangles. I'm going to use that maximum deviation. And like I said before, this way InstaLOD figures out when it is best to stop optimizing and keep everything intact. So I'm going to choose a number of 0.05 for the maximum deviation. And you can also see that we don't have any UVs for this model. So I've already turned off texture importance, and that way InstaLOD doesn't consider the UVs when it optimizes the mesh. So let's go ahead and optimize this selected mesh. And now one of the things that you'll notice is that this is only going to take, a couple of seconds. But you can see that we're optimizing a 400,000 triangle mesh here. So very quickly, we can see that InstaLOD is already done. And if I just scroll down to the bottom of the output log here, we can see that it took just a couple of seconds, and we've gone from 400,000 triangles down to about 6,500. Now, there is one issue that catches my eye, and that is these areas here where the individual CAD patch has not been bridged properly, and it's starting to drift now. And that is a common issue. It's also retained, if I go and zoom in here, those normals. And so that shading that was here in the original has been maintained because InstaLOD thought that this was important. So it's very important that you as the user have the correct shading on the input model and that you want InstaLOD to be able to optimize. That way you have the best output possible. One of the other things to note is that the tessellation in this area has been cleaned up quite a bit. So I'm just going to go ahead and turn on the shaded mode here, and you can see that there's a very hefty optimization here in the handle. Now, if we get down to the bottom, this has been cleaned up as well. But again, we've introduced too many errors here, so let's try and clean those up. Now with InstaLOD, we could use vertex welding by distance of the vertices, or we could try some T-junction healing. But for here, we're going to use lock boundaries. That way, the boundary shapes of the model don't change and it protects the gaps. So we're going to go ahead and hit Optimize Selected Meshes again. And again, this is only going to take a few seconds. But we should have a much better output than we had before by locking the boundaries. So if you want to see what InstaLOD is doing while it's processing, we can again go down to the output log, and you can see it's already done here. So I'm just going to pull this off to the side, and what you'll notice right away is that these gaps have been controlled for the most part. And, there is a gap here, but it's maintained from the original input mesh. So again, this should be cleaned up from the input mesh to produce the best output. But as we can see, we have a very clean front, and if I go ahead and scroll down here, you can see it's protected the shading and the boundaries below. So again, we've gone from 400,000 triangles, and for this optimization, we've gone down to just 10,000 triangles. And that's a very good optimization for what was a very messy input mesh. So thank you for taking a look at this CAD model optimization process. We hope you enjoyed the great things that you can do with InstaLOD when optimizing your meshes, and we look forward to seeing you in the next video. If you enjoyed this video, drop us a comment below, and don't forget to subscribe. For the latest news about InstaLOD, please visit our website and follow us on Twitter. You can find all the links in the video description below. Thanks for tuning in, and we'll see you in the next one.